All right, let's start. So we have 12 problems between this one and this one right here. We're going to do this together real quick. And then what we're going to do is the answers are here. Okay? So this is your answer bank right here. This is your answer bank. And once we've worked out all of these, we're going to cut them up and we're going to glue just a little top where the problem matches the answer. Okay? So it's not that hard to do, okay? Let's go ahead and start. We need two color highlighters. All right, rectangle ABC is dilated to rectangle A prime, B prime, C prime. Determine the scale factor. Okay, so it's going from here to there. Okay? So we're going to determine the scale factor, so we're going to say no to Oreos. Correct? So new over old. Very good. We're going to say no to Oreos. So let's highlight. All right. 4 to what? To 10. Thank you. This one's sleeping, right? And that one is standing up, right? Not dead. Thank you. Not dead. All right. So what's the new one? If it's going from the little one to the big one. The new one is, what's the measurement of the new one? 10. And then we're going to divide that by the old one, which is 4. Very good. And we're going to say 10 divided by 4. So 2.5 or 50, it's about the same thing. All right, so let's look for it over here. And that was the scale factor. So it's either that one. Oh, there it is. Scale factor, 2.5. We're not going to cut them yet, okay? So this one, the answer would be 2.5. All right. Yeah, is the scale factor new over old. All right. A cube is dilated by a scale factor of 5. That means that it is bigger or smaller? Bigger. It's the scale factor is 5, right? So it's going to be bigger. How many times bigger? 5 times bigger. Very good. Describe how this transformation will impact the surface area. Let's see. Let's say x is 1 on this one. I'm going to pick a really easy number. If the cube is dilated by a scale factor of 5, what would be the new measurements of the cube? 5. Very good. Now, what's special about a cube? All the sides are equal. Very good. So this is 1 and this is 1. And then on the other one, everything is 5. Everything is 5, right? All right, so let's calculate the surface area. How many faces does a cube have? 6. Very good. So let's calculate the surface area of the small one. What's the area of this face that I just colored? 1 times 1, which would be 1. Very good. But how many faces do you have? 5? 6. Think about a pair of dice. How many numbers does a pair of dice have? 1 through 6, right? So I'm going to have to multiply that by what? By 6. And the surface area is 6, right? Now, then you took that same cube and you multiplied by 5, right? And now all the sides are 5. So instead of 1 is 5. Instead of 1 is 5. And instead of 1 is 5. So what's the new surface area? What's the area of this one? 5 by 5. Very good. Which is what? And how many faces does it have? 6. So what is 6 quarters? 150. All right. So now let's figure out how much does it increase. How can I figure out how much does it increase? Well, I take the little one and I see how many times can it go inside the big one. So how can I figure that out? Division. Very good. So I'm going to say 150 divided by 6. By 6, right? Not 5, 6. What do we have? 25. Very good. So the new cube is 25 times the surface area is 25 times bigger. Very good. This is the surface area. So let's go ahead. Do we have that in here? All right. It will increase by 16.9. It will increase by 1/4. It will increase by 1.25 to the third. It's in the back? All right. Do you see it? I don't see it, but we did it right. What is 1.25 to the third? 1.95. All right. I know we did it right, so let's go ahead and skip that one, and maybe we, by process of elimination, can do that at the end, right? Figure out what the answer is. All right. Determine the volume after a dilation of 2. So if it's a dilation of 2, was it bigger or was it smaller? Bigger. Bigger, because it's bigger than 1. All right, so instead of 4, it becomes what? I'm recording. So if it's, instead of 4, it becomes what? The diameter is now 8. And instead of 10, the height is what? 20. Very good. Now, if the diameter is 8, how much is the radius? 4. So we got to figure out the volume. How do you figure out the volume? Do we have our cheat sheets? I don't think we do. Do we have our reference sheets? We forgot to pass out our reference sheets, please. Thank you. All right, how do you calculate the volume of a cylinder? Shh. How do you calculate the volume of a cylinder? Leslie, I am recording, for crying out loud. How do you calculate the volume of a cylinder? Big B times H. Very good. Where big B is the area of the base, which is the circle. Very good. And that would be pi r squared. Okay? All right, so pi is 3.14. What's the radius? 4. Right? Because I don't have this 4 anymore. It was dilated, and I don't have that 10 anymore. It was dilated. It was bigger. So the radius is 4. What about the height? 20. All right, so let's do it. (3.14) times 4 squared times 20. What do we got, babies? So 1004.8, and those would be, oh, I scratched them so I can't see them. Was it centimeters or meters? Oh, none of the above. Inches? All right, so cubic inches? Yes? All right. So let's see if we can find that. Look for that on the answer sheet. Can you see it? You found it. Yeah, there it is. It's right there. It's right there. All right. Yay? All right, let's do this one. All right. So we got to determine the scale factor. What have I told you that we need to do when it's mommy and then a baby inside? Thank you. So we're going to do a big one and then the little one. All right. How much is the big one? 10. Thank you. 4 plus 6. How much is the little one? 6. And we're going to say no to Oreo. So it's new over old. Okay, so kid is the little one. Do you see kid? That's why it's called kid, because it's the little one. And it goes to cat. So we're going from the little one to the big one. So what's the new one? 10 or 6? 10. Not 6. 10. And what's the old one? 6. All right, so let's simplify that. 10 divided by 6. 1.66666. All right, so let's see where we can find it. Scale factor. Oh, there it is. Scale factor 1.6. You see it? Yes? All right, let's highlight it. All right, next one. A trapezoid is dilated by a scale factor of 2.5. Determine how this transformation will impact the perimeter. All right, so let's make a trapezoid. Yay? All right, I'm going to say that this is 2 and 2, 4 and 6. What's the perimeter of this guy? What do you do for the perimeter? Add them all up. Very good. So 6 and 4 is 10. 12 and 14. Now, the new one is bigger, correct? And it's bigger by what scale factor? 2.5. So what do I have to do with all those numbers? Multiply them by 2.5. 2.5. Very good. So let's start with 4. 4 times 2.5. How much is that? 10. Very good. 10. All right, what about 2? 2 times 2.5. Very good. That will be 5. So this is 5. And that one is 5 as well. And then what is 6 times 2.5? 15. Very good. So now let's add them all up. 10, 25, 35. All right, so now if I want to figure out what will it do, or how many times bigger is it? Divide. All right, so 35 divided by 14. 2.5? Yes? 2.5. All right. So let's see what we got. We already had this one, right? Or did we not? It will not decrease. It will not decrease. It will do what? It will increase. This one? No, that one's the scale factor. This one is that one. You know what? Why don't we just go ahead and start cutting and gluing, and that way we don't get confused. Yeah, let's do that. Let's cut. Yeah, we need to do something because this is not working out, right? Okay, let's cut it. Let's just cut them. Let's cut those 3. Those 4. Let's just cut the whole first page that we've already done. Because I'm getting confused. I can't imagine that you guys are probably getting confused as well. Oh, that one was on the website. You guys don't like it? We're recording. Be careful what you say, please. Yeah, cut them all. That first page that we were doing. And then we can just go ahead and start gluing and not worried about this because it's getting a little confusing. All right, where's my 2.5? I can't see it. There it is. That one goes there. But we're only going to glue the top, guys. Don't go crazy gluing the whole thing, okay? Like, yeah, so that you can flip it. Let me show you, Ricardito. These two go together. Scale factor 2.5 and this one go together. You're only going to put glue, Ricardo. Look, you're only going to put glue at the top so you can do this. You see that? Yay? Because there's your 2.5 and there's your 2.5. All right. All right. Oh, this one was the volume one, right? 10,000. Yeah, that was this right here. So that one goes there. Look at the volume. And look at that. And then this one, the trapezoids is here because it will increase by 2.5. And we got 2.5, right? So the rectangles go in the 2.5, right? The trapezoids go in the, it will increase by 2.5. And then the cylinder goes with the volume. And then the 1.6 is in the other side, so I'm going to wait. We can go ahead and cut the other ones too if you want to once you finish. All right, have we glued this one? That, huh? No, this one is the one that we don't know yet. Yeah, that's 25. We don't know yet. We're going to put this one separate, right? Because we don't know. We said it was going to be 25 times bigger, but we cannot find a 25 over here, right? So we're going to put it aside. Put that cube aside. And then this one goes in the 1.6, correct? The kid and the cat. The Kit Kat. The Kit Kat. They really do. It's one of my favorite candies. Alright, so 1.6 goes over here. hmm What? You can. If you finish cutting everything, yes, you can. 5:30. Just on Fridays. The rest of the days is until 4:30. Alright, are we good? So this one goes here. And then we already have 3 in the back, right? Yay, babies? Yay? Alright, so let's pick one to do. You want the trapezoid? This one? That one? Alright, so let's do this one then. Alright, this one says, this rectangular prism is dilated by a factor of 1/4. So is it going to be bigger or is it going to be smaller? Smaller, because it's 1/4. That's less than 1, right? Which means we got to figure out the volume. So let's give ourselves some numbers, okay? I'm going to say that this is 8, that is 4, and that is 4. It doesn't matter what numbers you pick. You just got to be able to divide them by 4, right? Or multiply them by 1/4. Let's multiply them by 1/4. That's probably the best way to do this. All right, so what about the new, let's calculate the volume of this one. What's the volume of the big one? pH plus 2B. Yay? Is that how you calculate? Is that surface area or volume? Ah, that's surface area. I'm sorry. So that would be big B times H, right? For a minute there, I thought it was surface area. I'm sorry, guys. It's volume. So big B times H. All right. This is my base at the bottom. How do you calculate the area of that rectangle? How do you calculate the area of that rectangle? How do you calculate the area of rectangles? If you don't know it, look for it. Base times, no, that's the triangle. Base times height. Very good. So what's the base and the height? 8 and 4. So that would be 8 times 4. And then what's the height of the? It would be 4. So can somebody do 8 times 4 times 4 for me? 8 times 4 times 4. No. 8 times 4 times 4. 128. All right. Now what about the volume of the small? The small one is a scale factor of 1/4. So instead of 8, how much is it? 8 times 1/4. How much is that? 2. Do you see it? So now instead of 8, it will be 2. What about instead of 4? What's 1/4 of 4? Thank you. 1. Thank you. For those of you that cannot see it, write it out. That will be 1. So this is a 1, and that's a 1. Miguel, close the door. All right, so over here, the area of the base, 2 times 2 times 1. And what's the height now? It's 1. So 2 times 1 times 1, 2. And what do I have to do now to figure out if it's going from here to here? New over old, right? What's the new one? 2. And what's the old one? All right, so can we simplify that? One over 64. So it would be 64 times bigger or smaller? Really? It's going from the big one to this. Okay, it's 64 times smaller. All right, so let's see. Do we have that in here? Oh, there it is. 1 over 64. So let's glue that one there. I think we did something wrong with the other one. We probably did big over small instead of small over big. All right, so 1 over 64. The one of them is 64 times bigger than the other one, or 64 times smaller than the other one. Shh, stop. So that one goes over here. All right, let me see what we did. We might have done, I think we did something wrong on this one. Let me go back to this one. It's dilated by a scale factor of 5. Determine how this formation will impact it. You know, we did it right. All right, I'm going to put it to the side because I'm not sure. Shh. Boys, do we need to move over here, please? So we need to be focused because I'm not stopping my class every 5 minutes because somebody in that table is playing, and it sure is not Iris. All right, let's do this one now. A square has a side length of 3.5 meters. What's special about a square? Very good. All sides are the same. Determine the side lengths after a dilation of 3/5. So what do I have to do with that 3.5? What do I have to do with that 3.5? Multiply it. Very good. You always multiply it when you're doing scale factors. When you're doing dilations or scale factors. All right, so what do I multiply that by? Times what? We don't know what we're doing, do we? No, we sure don't. Dilations are either going to make something bigger or smaller because there's a scale factor. We saw it when we did similar figures. So you always multiply. So what would be the side lengths? Okay, I'm dying here. I am dying here because everybody's just doing whatever they need to be. No, not whatever they need to be doing. You don't need to be cutting right now. You need to be paying attention to me. Stop cutting. Because nobody's answering me. That means you're not paying attention to what I'm doing. So what's the purpose of doing the activity if you're not paying attention to me? What is the side length of the new one? Thank you. It's right there, 2.1. But you can't do it because you're not paying attention to what I'm saying. You can't say it because you're too busy cutting. Come on. All right. There it is. There it is. So we glue that one over there. That one goes there with a 2.1. If you need to cut, please cut now so that you're not wasting time cutting and not paying attention to what I'm doing once I start explaining. Hurry up. All right. If you've already cut, this is the next one that we're doing. All right. So runs is dilated by a scale factor of 0.75. Is that going to be bigger or smaller? Why bigger if it's only 0.75 of it? If I tell you to give me 0.75 of your chocolate, you're going to give me the whole chocolate? I'm asking you for 3/4 of it, right? To create trapezoid, gone. And we got to figure out x. All right, so x, yeah, corresponds to what? To 4. If you don't know, what have I taught you to do? Didn't I teach you to do this? RS to GE. Okay, Jonathan, hurry up. Hurry up and cut. Hurry up and cut. I need you to finish cutting, baby. RS to GE. GE, RS. All right, so we got to determine the length of x. So what do we have to do with the 4? Multiplied by what? Thank you, because that's the scale factor. 4 times 0.75, and that would be 3. So x equals 3. I don't see it in the front, so it has to be in the back. Do you see it in the back, guys? Yeah. Yeah, the length is 3, so this goes there. Right here. That goes there. That goes there. 3. Yay? All right, we got it? Let's do this one now. All right, we're going to determine the volume after a dilation of 1/3. Bigger or smaller? If it's just 1/3 of it. Smaller. If it's just 1/3, is 1 out of 3, right? So it's going to be a lot smaller. So what do you got to do with all those numbers? Divide by 3 or multiply by 1/3. I want to multiply just to get in the habit of multiplying, okay? So 15.9 times 1/3. That will be 5.3. So instead of 15.9, is 5.3. All right, 63.3 times 1/3. 21.1 and 27 times 1/3. That 1/3 of 9 will be 1/3 of 27 will be 9. Very good. All right. So the volume would be length times width times height. So you got to take those three numbers and do what? Multiply it. So 9 times 21.1 times 5.3. And you get 1,047. And those would be cubic inches. There it is. It's at the top, right? That one right there? This one? All right, are we good? That one goes there. Can we move on to the next one? All right, let's do the sphere now. All right, so a scale factor of 1.25. Is it going to be bigger or smaller? If it's 1.25. Bigger. It's a whole and then 0.25 more, so it's going to be bigger. Very good. Now, how do you calculate the volume of a sphere? 4/3 pi r cube. It's on your formula, right? All right. So let's make up some numbers. Let's say this is 1. What is the new radius? You got to multiply that by what? By 1.25, which would be what? 1.25. See why I pick 1 and not 2 or 3 or 4? Because it's a lot easier, right? Smaller numbers are a lot easier, and multiplying by 1 is just the same number. So the new radius is 1.25. And the old radius would be 1. So we got to do the volume of the small. That is 4/3 times 3.14 times what? No, the small one first. 1 cube. All right, let's do that. So that's how it should be looking? Yes? 4/3 times 3.14 times 1 to the third power? Thank you. All right. So what do we got? Uh-oh. All right, I lost it. All right, 4.19. I don't know. Sometimes it doesn't work. That's why you got to be careful. Because volume is 3 times. So it might be 1.25 to the third power. Okay? Because volume has 3 units. Square has 2, but volume has 3. All right, let's do the big one. 4 thirds, 3.14, and instead of 1 is 1.25 cube. So let's write that. 8.18. All right, does your theory work, Miguel? You want to try it out? You want to say 4.19 times 1.25? Is that the same? No, it's not. But let's do my theory. 4.19 times 1.25 to the third power. Because there's 3 of them. Huh? There it is. Yay? So it's 1.25 to the third because volume has how many units? 3. But if it would have been area, it would have been 2 squared. It would have been square or to the second power, not 3. All right, so which one is your answer? Oh, there it is. By 1.25 to the third power. Very good. So let's glue that in. Those two go together. Yay? All right, so volume is the scale factor to the third power, but surface area will be the scale factor to the third power or second power? All right, I'm going to say it again. Volume is to what power? Third. But area is to what? Very good. So volume is to the third power, right? But area is to the second because area is always squared, right? And volume is always cube. All right. So look, let's do that, and we're working way too hard. So let's do that. A pyramid is dilated by a scale factor of 4 thirds, right? Determine how this transformation will impact the surface area. So would that be square or would that be cube? 2 or 3? If it's area. Squared. So that would be 2, right? So what do you got to do? You got to take that scale factor and cube it or square it? Square it. There you go. So let's square it. Four thirds to the second power. How much? It's 16 over what? 9. Phones. Put them on vibrate, please. All right, so what's my answer? It will what? It will increase by 16 over 9. Yes, it's that easy. If you understand that volume is cube and that square, that area is square, you're good to go. Yeah, we were doing a whole lot of work, but I wanted somebody to figure it out, and we didn't. No, we didn't. Miguel was the closest one that said, can we just multiply by the scale factor? And he wasn't right, but we do need to do something with that scale factor, right? All right, so let's do this one. The last one, right? No. We've already done this. We just don't know where the answer is. All right, a circle is dilated by a scale factor of 1/4. How will this impact the area? What do we do with the scale factor? Square it or cube it? Square it. Very good. So 1/4 squared. And that will be 1/16. Yes? All right, so it will be what? It would increase by 1/16. So that would be here. Oh, well, it will decrease, yes, because it's 1/4. And then I told you that it works, right? The other one goes in that blank spot. But it's actually not decrease. It should be increase. All right, so this one goes here. Yay? That will be 1/16. And then the last one should go over here. Because this is the only spot we got. Yay? Are we good, my babies? All right. Put that in your notebook. Classwork, yes. Yeah, we don't have a tab for tutorials. We should have done one, but too late. It's okay. Not a big deal. All right. Go. Go. You need to go? All right. So put the glue away. We don't need it anymore. All right. Let's go here real quick. I want to finish this before we go. I thought we were going to have time to work on activities, but no, it's not. Not even 5. All right. You ready? So everybody has a set of cards. And then this is where you keep your answers, okay? You good? Everybody with me? Yeah, we're doing the cards. All right, what I'm going to do is I'm going to go ahead and highlight only the one that is new, okay? You know the one that is new, but because it has those, oh, it has those little lines over there at the top. It's A prime, B prime, and C prime. That's the new one. I am only going to highlight the new one. Or color the new one. That's the new one. So this one goes from big to small, right? Because the other, yes, because the other triangle is bigger. Can you see it? Stop tuning me out. Come on, babies. Yes or no? All right. So Andrew says that the scale factors used was 3/2. Annie says that the scale factor used was 2/3. So for the scale factor, you're going to say no to Oreos, right? New over old. All right, what's my new one? Take one of the sides and measured. 1, 2, 3, and 4. What's the old one? 1, 2, 3, 4, 5, and 6, and we're going to tell the calculator to simplify it for me. I'm not even gonna simplify it. She's gonna do it. 4 oh yeah, why not? 4 6. Especially for those of you that don't know how to do it. All right. So who's right? Is it Andrew or is it Annie? Annie is right. Very good. So you can, yeah, we can shade Annie. Or you can just highlight Annie. And then over here, why is she right? Oh my God. Because it's a reduction. What does it mean to be a reduction? That the scale factor has to be less than 1. Can you divide 2 by 3? What is that? 2/3. 0.66666666, right? I'm going to round it to 0.67. What is 3 divided by 2? 1.5. That has to be, that's not a reduction. What is this? Enlargement, right? You're going to make it bigger, but in here you're going to make it smaller. So that's why she's right, because it's a reduction, and the scale factor has to be less than 1. So scale factor has to be less than 1. All right, let's go to card 2. Okay, come on, guys. Come on. You need to watch that video so you know what you're doing. All right, 2. A figure on a coordinate plane is dilated from point A to point B. So it goes from 3 9 to 1 3. So it's decreasing. Very good. Very good. It goes from 3 to what? To 1, and from 9 to 3. So look at it and tell me who's right. Is it Bobby? That says that it is 1/3 of the x and 1/3 of the y. Or is it Betty that says that is 3 times the x and 3 times the y? So, so, alright. Alright, so it gets smaller, right? So wouldn't that make it 3 times bigger? Yeah, only because I made a face. And if it's not Betty, it has to be what? Bobby. If it's not night, it's day. Right? Alright, thank you. Alright, again, shh. 3x would make it 3 times bigger. This one, what would it do if it's 1/3 of it? Well, it would reduce it by how many times? 3. Thank you. It would reduce it by 3 times. So the correct answer is Bobby, because it is a reduction. Because it is a reduction. I know Bobbies that are not white. Yes. All right, number 3. Shh. All right, let's highlight let's color the new one. Which one is the new one? D, E, F, or D prime, E prime, F prime? All right, so the big one, right? So is this a reduction or an enlargement? Enlargement, thank you very much. So if it's an enlargement, The scale factor has to be less than 1 or bigger than 1? Bigger than 1. So let's figure out which one is bigger than 1. Is it 5 halves or is it 3 halves? Can you do it before we answer? Because what's 5 halves? Is that bigger than 1? Yes. Let's do the next one. Alright, so that one doesn't help. So I'm going to have to actually calculate it, right? Yes? Alright, so say no to Oreos. New over old. Let's do this side. That's the easiest one to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And that side corresponds to D and E, right? So 1, 2, 3, and 4. And let's see. I rather do it as a fraction, and then I don't have to even think about it. I just do 10 over 4, and she will give it to me as a fraction, and I don't have to change anything. So who's correct? Carl. Yes. My niece is too, and I saw it plenty of times. Alright, so it's correct because it's what? Because the scale factor is it's 5 over 2, right? Are you with me? Alright, let's do card 4. A figure on a coordinate plane is dilated using the rule 6/5 x, 6/5. What does it mean? You're going to take all your values of x and do what with it? Times 6/5. And you're going to take all your values of y and multiply it by 6/5. So is it Derek that says it's a reduction, or is it Delilah that says that it's an enlargement? Let's see. 6 divided by 5. 1.2. So the scale factor is 6/5, which is 1.2. Is that bigger than 1? So is it an enlargement or is it a reduction? So if it's bigger than 1, it's a reduction? Oh my goodness. Why is she right? Why is Delilah correct? Why is it an enlargement? Why is Delilah correct? Not the number. What is it called? Thank you. Because the scale factor is 1.2, which is bigger than. When you multiply by 1, do you change it? If I have $1 and I multiply by 1, still the same. But if I multiply by 10, how many dollars do I have now? 10. But if I take my dollar and I multiply by 1/2, how much money do I have? So that's a reduction. And is 1/2 bigger than 1? No, it's half. Can we think before we speak? So we don't sound like we don't know what we're talking about? Yes, we can. No, we need to learn. Because you're not going to have any cheat sheets. Alright, so Delilah is correct because, tell me again. What's the scale factor? If you wrote it, you should know. What is it? 1.2, which means it's what? Bigger than 1. So it is an enlargement. Yay? Alright, card 5. Let's highlight the new one. Which one is the new one? Big one or small one? Small one. That's the small one. How do you know that that's the new one? It's got the little primes. Very good. So is this going to be enlargement or reduction? Most definitely reduction. Scale factor, bigger than 1 or smaller than 1? Less than 1. Thank you very much. If it's bigger than 1, it multiplies it and it makes it bigger. If it's 2, you double it. If it's 3, you triple it. You just made it bigger. Those are all numbers that are bigger than 1. All right. So Emmett says that it's 1/2. And Emily says that it's 1/3. So we got to count. Let's see. We got to count, right? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Yes, you can. I was about to do that. For those of you that can't see it, just do it by the number. That's a 0, right? It goes all the way to 9. So there's 9. And then it goes all the way to -9. So that's another 9. Which is 9 plus 9, 18. Now what about here? It goes all the way to 3. So that's 3. It goes all the way to -3. So another 3. So what's the whole thing? 6. Now you got to say no to Oreos, right? New over old. Miguel, people cannot do it as fast as you can, and we obviously do not know how to do this, so you need to give them some thinking time, please. What's the new one? 18. See? The new one is not 18. That's why I highlighted the new one, right? So that you go to the highlighted first. All right. And then simplify it. Stop playing. Take it off. All right. And the calculator will do everything for you. You don't need to worry about any of that. So it would be 1/3. So who's right? Emily or Emmett? Emily. Emily's right. Because the scale factor equals 1/3. And it's most definitely a reduction. All right, are we good? All right, a figure in a coordinate plane is dilated. The image is larger than the pre-image. So it goes from small to large, right? Finn says that it is possible that the scale factor could have been a fraction. Fiona says that it is not possible for the scale factor to have been a fraction. So who's right? Fiona? All right, so if it goes from small to large, the scale factor has to be bigger than what? Bigger than 1, right? So Fiona's right? I'm not going to highlight her. So that's a fraction, correct? Is that bigger than 1? Is 5 divided by 2 bigger than 1? So who's right? She says that it cannot be possible for the scale factor to have been a fraction. Yes, it can. It's just got to be a number that's what? Bigger than 1. So it's Vin. He's correct because, or should I say, as long as it is a fraction bigger than Bigger than 1. That's how tired I am. All right, ready for the next one? All right. All right, so rectangle BCD will be dilated by a scale factor of 3/2. Gabe says that it will be reduced. But Gabby says that it would be enlarged. Who's right? How do you know that Gabby's right? Very good. 3 divided by 2 is what? 1.5. The scale factor is 1.5, and that's most definitely bigger than 1, which means it will make it larger. So Gabby is correct. Because 3/2 is bigger than 1. Yeah, the problems are not hard. All right, a figure on a coordinate plane is dilated by a scale factor less than 1. So bigger or smaller? If it's less than 1, smaller. So Henry says that the two figures will be the same, congruent. Will they be the same? Heck no. No, if they're the same, you multiply them by what? By 1. Heather says that the two figures will be similar. So who's right? The same shape, but different size, like me and Miss Marine's picture. Very good. Okay? So Heather. Just copy the name and we'll be good for the last ones, okay? All right, we got 2 more. All right, triangle TUV will be dilated by a scale factor of 2. So is it going to be bigger or smaller? Bigger. How do you know that it's going to be bigger? Because 2 is bigger than 1. Very good. Isaac says that T will be located at 420. Where's T? T is right here, right? So what are the coordinates of T? 2 and? What are the coordinates of T, of point T? 2 and 10. If it's a scale factor of 2, what do you got to do with those two numbers? Multiply them by what? By 2, right? So this would be 2x and 2y. You take all your x's and you multiply them by 2. You take all your y's and you multiply them by 2. 2 times 2? 4. 2 times 10? Is Isaac correct? Yes, he is. I'm not even looking at Isabel. All right, so Isaac, right? Isaac. All right, let's do the last one. A figure on a coordinate plane is dilated by a scale factor of 3/4. So, bigger or smaller? Really? Oh my God, we can't even take the darn calculator and say 3 divided by 4 and figure out if it's bigger than 1 or smaller than 1. Can we please do it? For those of you that just want to answer and without even thinking about it. That was you, Miguel. I know it is because I heard their voices, not yours. All right. So what is the scale factor? 0.75, right? So the scale factor is 3/4, which is 0.75. It's not a whole. It's 3 out of 4. That's not a whole, so it's less than 1. To be bigger than 1, it needs to be 5 over 4, 6 over 4, 7 over 4. You got your 4 and then some more. All right. So Jeremy says this dilation can be represented by x plus 3/4, y plus 3/4. Julie says that no, you don't add. You say 3/4 times x and 3/4 times y. So which one is correct? Which one is correct? How do you know that Julie is correct? Yeah, we don't know. Uh, wait, you guys don't know what you're doing. No, which means I'm teaching until 5:30. All right. So it's Julie. Have we added in here? All we've done is what? Multiply. That's simple. All we've done is multiply. That's all we've done. So that should have been eliminated right off the bat because we haven't added at all. Not at all. Oh my God. Guys, I don't understand. This is not